All right, this is Algebra 3, Section 9.3, talking about matrix operations. Now, I know I haven't done this with you guys before, so this might be a first time, but some things just to remember. I know on this video now, I'm going to go through this fairly quickly, but just remember at any time, if you need to pause it and write stuff down. You can always pause it at any time you want. You can always go back, rewind, and all those kind of things as I go through this. Okay, so section 9.3, we're talking about matrices and a matrix. So what is a matrix? I mean, that's what our question is here. So a matrix is very simply just a way to organize a set of numbers. And eventually what you're going to do here is you're going to solve systems using matrices, which is actually somewhat easier. But in this section, we're going to end up adding, subtracting, and then doing what we call scalar multiplication with it just in this section. Okay, so again, a couple things here on matrices. It's a way to organize. So we're looking at this and we're saying, okay, this is an example of a matrix, of a picture of a matrix. Okay. In this case, I have 3 by 3, which means there's 3 columns or n columns and m rows. Okay. In this case, this is a 3 by 3 matrix because it's got 3 columns and 3 rows. Okay. So you see here where it says A11. Okay, that's just the first column, first row number. This is always going to be a number. But this designates, okay, first column, first row. Excuse me, first row, first column. Yes, first column, first row. First column, first row, second column. First row, third column. Okay, this is an example of, okay, this is the second row, first column, second row, second column, second row, third column. Rows always come first, columns always come second. So they're going to ask you for what is the order of the matrix. Well, it's denoted as the number of rows by the number of columns. So for example here, A is the matrix with these 6 numbers, okay, and we want to know what the order is. Well, in this case, you see we have 2 rows and we have 3 columns. So this matrix is a 2 by 3 matrix. Okay, same thing here. What's the order of matrix B? Well, in matrix B, we have 3 columns, or excuse me, we have 2 rows. Excuse me, we have 3 rows and we have 2 columns. Okay, three rows, 2 columns. Again, remember, rows go this way, columns go this way. Okay, so we've got 3 rows and we've got 2 columns. So this is a 3 by 2 matrix. All right, equality of matrices. Well, 2 matrices are equal. This is very simple. 2 matrices are equal if and only if they have the same order and all of the things that are in there are exactly the same. Okay? So as you see here on this matrix, we have the matrix A and the matrix B. Well, if A is equal to B, if and only if all these numbers match up. So for example, 6 and 6 has to be the same. Well, what would Z have to be for it to be the same? Well, Z would have to be 3. Okay? Again, numbers in the same position have to be exactly the same. So, X would be 1. And then Y plus 1 would have to be 5, which means Y would be 4. Okay? So, 2 matrices that are equal have the same order. These are 2 by 2 matrices, 2 rows, 2 columns, okay, and their numbers inside of them are exactly the same. Okay, so let's actually dive into the operations of the matrices. So let's take a look here at matrix addition and subtraction. Okay. Now, one of the things that are key about matrix addition and subtraction is they have to be of the same order. Otherwise, you cannot add or subtract them. So they have to be both 2 by 2, or both 3 by 2, or both 2 by 3, but they have to be the exact same order. Okay. So in this case, we have two 2 by 3 matrices. This is a 2 by 3 matrix. This is a 2 by 3 matrix. Okay? And so what we're going to do now is we're going to add them. And this is very, very simple. You simply add or subtract the terms that are in the same position. Okay? So if I add these guys, the numbers in the very first position, okay, 0 plus negative 2. These two numbers right here are in the same position. So I'm going to add those together and get negative 2. 5 plus 3 gives me 8. 3 plus 5 gives me 8. Negative 2 plus 7 gives me 5. 6 plus negative 9 is negative 3. And negative 8 and positive 6 is negative 2. And you have just now added your very first matrix. Okay? So adding matrices is really fairly simple. Another example, this one is of subtracting matrices. So now I'm going to take these two matrices. These are 2 by 2 matrices. They're the same matrix, so I can add or subtract them. And again, I'm going to subtract parts that are the same, or in the same position. So negative 6 minus negative 5. Well, if I go negative 6 minus negative 5, it's really negative 6 plus 5, so that's negative 1. 7 minus 6 is positive 1. 2 minus 0 is 2. And negative 3 minus negative 4 becomes negative 3 plus 4, which is 1. Notice, if I add a 2 by 2 matrix, or subtract a 2 by 2 matrix by a 2 by 2 matrix, I end up with a 2 by 2 matrix. So that's being able to add and subtract matrices. Alright, scalar multiplication now. Scalar multiplication is very, very similar to the distributive property. Okay? If A is a matrix with order of m times n, and C is a scalar multiplier, then C times the matrix A means you multiply every term by C. Okay? So for example here, I have two matrices. I've got a matrix A, and a matrix B. And I want you to take 4 times matrix A. So what we're going to do here, 4 times matrix A, which is negative 1, 4, 3, and 0. So now what I'm going to do now is take negative 4 times, 4 times negative 1, that's negative 4. 4 times 4, that's 16. 4 times 3, that's 12. And 4 times 6 is 24. And you now have used a scalar multiplier. Okay, so again, very similar to the distributive property. You are simply just multiplying this by everything. Another example, I want to take negative 5 times B. So negative 5 times matrix B, which matrix B is 2, negative 3, 5, and negative 6, which if I multiply that negative 5 through, I get negative 10, I get 15, I get negative 25, and I get 30. And that's using a scalar multiplier. Okay, so now down here on the bottom, I've got 2 scalar multipliers, and we're going to add them together. So I want to take 2 times A, matrix A, and 3 times matrix B. So 2 times matrix A, which is negative 1, 4, 3, and 0, plus 3 times matrix B, which is 2, negative 3, 5, and negative 6. So I'm going to go ahead and distribute both of these. So this is going to be the matrix negative 2, 8, 6, and 0, plus matrix 6, negative 9, 15, and negative 18. And now I'm simply going to add, because these two matrices are 2 by 2s, I'm going to add similar spots. And I'm going to end up with negative 2 and positive 6 is 4. 8 and negative 9 is negative 1. 6 and 15 is 21. And 0 and negative 18 is negative 18. Okay, so you can use scalar multiplication with addition or with subtraction as well. Okay, last part of this section is being able to solve a matrix equation. Okay, so when we're solving a matrix equation, two of the things we're going to do here. First, we got to solve the equation for x. We're going to get x by itself. Then we're going to substitute in the matrices, and we're going to simplify this thing. Okay, so I've given you two matrices here. A is 1, negative 5, 0, and 2. B is negative 6, 5, 9, and 1. And what I want you to do is I want you to find 2x plus a equals b. Okay, so one of the first things we're doing here is we're solving the equation for x. So I subtracted a, and then I divided by 2. Now, b minus a divided by 2 is the same thing as taking 1/2 times b minus a. So I'm going to, when I plug these in, I'm going to make it look like that one. So what this is going to look like now, this is going to be 1/2 times matrix B, which is negative 6, 5, 9, and 1, minus matrix A, which is 1, negative 5, 0, and 2. Okay, so order of operations tells me I got to do my inside the parentheses first. So I'm going to go ahead and subtract these two matrices, and I got 1/2 times the matrix. If I subtract them, negative 6 minus 1 is negative 7. 5 minus negative 5 becomes 5 plus 5, which is 10. 9 minus 6 is 3, and 1 minus 2 is negative 1. Okay, and now what I'm going to do now is distribute my 1/2 and use my scalar multiplier. So this ends up being negative 7 halves. 1/2 times negative 7. 3 halves. Half of 10 is 5. And 1/2 times negative 1 is negative 1/2. So now you have simplified. This is your final answer for that equation. Okay. Let's take a look at this last example here. 3x minus 2a equals b. First thing I got to do here is get x by itself. So I got 3x. I'm going to add 2a to the other side. b plus 2a. And then I'm going to divide both sides by 3 because I want to get x by itself. Now, so x equals b plus 2a all divided by 3. Or I'm going to write it like this. X equals 1/3 times b plus 2a. Okay, so when I plug these in now, it's going to be 1/3 times the matrix B, which B is -6, 5, 9, and 1. And we're going to add that to 2 times matrix A, which is 1, -5, 0, and 2. Okay, so now on this one, I'm going to distribute my 2 and then add and then multiply everything by a third. So distribute my 2. I'm still going to have -6, 5, 9, and 1 plus 2, -10, 0, and 4. And then at the end, we're going to multiply it all by a third. So I'm going to add these guys together here now. Okay, add these guys together. So this is going to be 1/3 times the matrix. -6 plus 2 is -4. 5 plus -10 is -5. 9 plus 0 is 9. 1 plus 4 is 5. And then I'm going to distribute that 1/3. So this is going to end up being -4/3, -5/3. 9 divided by 3, 9 times 1/3, 9 divided by 3 is 3. And then +5/3. Okay. So now you should be able to add, subtract, and then do some scalar multiplication along with being able to solve some basic equations of matrices. Okay, now just remember, I know I went through this fast and it's a little bit of a long video, but you can always go back and look at things if you need to. Okay, you should be able to complete your assignment. Your assignment is up there on the board for Thursday. Make sure you work on that for the rest of the period.